Welcome to Visiting Professors and Practitioners 3-in-1 program, Theory and Application of Autonomy System on Ships. First of all, let us pray and praise to Allah Subhanahu wa Ta'ala. Because of His blessing and mercy, we can come together without any obstacle here with healthy condition in the webinar of 3-in-1 program of Brawijaya University. Second, let us greet and pray to our beloved Prophet Muhammad SAW, who had brought us to the path of light and left the darkness in this life. I am Nabila Putri Delinda, your host for today. I also would like to greet Mr. Ardana Wicaksono, PhD, from Research Department of Bruno Electric Co., Ltd., Japan, our lecturer, Mr. Muammar Khadafi, STMT, from Brawijaya University, our lecturer, Mr. Sunardi, STMT, from Brawijaya University, and all my friends, students here. Ladies and gentlemen, before we come to the main season, let us start this by praying first, so the event that we'll hold on this day will run well without any obstacle at all. Pray based on individual beliefs begins. Amen. Ladies and gentlemen, to complete the opening ceremony today, we have to singing the national anthem of Indonesia Raya. Thank you very much for singing Indonesia Raya, bro. Ladies and gentlemen, please allow me first to read the agenda for today. The first agenda is the opening season. Second agenda is the speech from Mr. Gatot as speakers today, maybe or just speech for today, and Mr. Ardana Wicaksono, PhD, as speaker today from Research Department of Bruno Electric Co., Ltd., Japan. Fourth agenda is the general lecture, which will be delivered by Mr. Ardana Wicaksono, PhD. The sixth agenda is question and answer session. The seventh agenda is photo session, and the last one is closing. Ladies and gentlemen, before we go to the main agenda, please welcome for Mr. Dr. Insinyur Gatot Bintoro, MSc, for the speech session. Mr. Gatot Bintoro, the time is yours.
Yeah, okay, thank you very much, moderator. I'm very sorry because I have problem with my camera probably, so I do not put on my camera. I appreciate this program, 3-in-1 program for our study program, utilization fisheries resource study program. And I think this is the third or fourth program. Hopefully this program will be very helpful and very important for students to increase their knowledge. Yeah. Now it's about fishing vessel, if I'm not wrong. Yeah, Pak Gaddafi, is it right about fishing vessel?
Yes, right.
Yeah. So I think this is the also important or supporting information or knowledge for students who take the fishing vessel subject and also fishing machine. Yeah, and I appreciate the Dr. Ardana Wicaksono. Welcome for giving his material. Hopefully, this will continue our working together, yeah, to increase our knowledge about fishing vessel information and in our study program. And for students, please keep in your mind and please pay attention. Yeah, hopefully you will not have any difficulty to understand the material. Yeah. I think that's all, moderator, for me as one of senior lecturer in utilization resource fisheries study program. Hopefully, again, this will be helpful or give more information not only for students but also for us as lecturers. Yeah, I think very important information and knowledge. Thank you very much. I give back to the moderator for the next chance. Thank you.
Thank you very much, Mr. Dr. Insinyur Gatot Bintoro MSc for the speech. And now the third agenda is the speech from Mr. Ardana Wicaksono, PhD, as speakers today from Research Department of Furuno Electric Co. Ltd, Japan. Mr. Ardana, the time is yours.
Okay, thank you very much, Dr. Gatot, and also my senior, Pak Gaddafi, and also Pak Sunardi. So I wonder, should I present in English or in Bahasa or in Japanese today? Thank you for, as I said, Pak Gatot, Pak Sunardi, Pak Gaddafi for the invitation. I've been working in Furuno Electric since 2019 and actually mainly as a researcher for the ship control system or algorithm, mainly focusing on the autonomous ship system. Well, maybe everyone knows that Furuno Electric has quite extensive products on the fishing support system, like we can say sonar and fish finder and all those kind of range of product, because actually Furuno Electric was founded in 1948, I think, 3 years after the World War II. And the first product is the fish finder. So I hope I can give some insight about the fishing vessel or fish finder, even though my presentation today will be mostly, how to say, focused to the ship problem itself. I think that's all for me. And I was graduated from ITS, Ocean Engineering. I was a class of 2009. So we have me and Pak Sunardi has a 10 years difference. So yeah, hopefully today I can share some useful information about autonomous ship. I think that's all for me. Thank you.
That's such a wonderful speech from Mr. Ardana Wicaksono. Thank you very much for your speech. All right, ladies and gentlemen, Now we come into the main agenda, that is webinar of visiting professors and practitioners 3-in-1 program, theory application of autonomy systems on ships. In this session, will be guided by a moderator. Please welcome our moderator, Mr. Muammar Gaddafi, STNT. The time is yours.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. And also thank you for Master Ceremony for give me the time as a moderator in this session. And first of all, I would like to say thank to the Almighty God for give us not only mercy and blessing, but also health and opportunity to attending this seminar or this virtual class. Second is we deliver to greetings to the messenger of God, and I'm going to share the CV of our speaker in this session. He is Mr. Dr. Engineering Ardana Wicaksono, and currently he works in Furono Electric, Japan, and as a researcher in research department. And for now, I will give time to Mr. Ardana Wicaksono to give the material. Time source.
So again, I would like to say thank you for everyone to attend this seminar on this beautiful Saturday in the middle of Ramadan. Yeah, hopefully the blessing of God can shower to us, and then we can learn a lot of things, not only the students, not only the lecturer from the Brawijaya University side, but also from me. I hope I can learn a lot from what the UB has been doing for the study on the fishing vessel and the fishing technology. So, okay, I will just continue in English, but if anyone need explanation in Bahasa, or if my speech is too fast, please interrupt me at any time. So this is the title is the theory and application of autonomous systems on ships, and I put one here, the first like first one, because the second will be next week. And yeah, let me continue to the second slide. So previously, Mr. Gaddafi has explained a little bit about my CV, but I will explain it again for a while. So I did my bachelor degree in the Technical Lautan in Ocean Engineering in ITS Surabaya. Then I returned to my house in Jakarta, and I worked for half a year in Tugu Pratama Indonesia here. It is actually a insurance company owned by Pertamina. So I was working as a risk engineer. I did risk evaluation to the gold mine, to the beauty clinic, to factories, a lot of things. It's a general insurance. And then just the third month when I start working, so my application for the MEXT scholarship Mombu Kagakusho, so it's the Ministry of Education in Japan, was accepted. So it was a 5-year scholarship for a master and doctor of engineering, but this doctor of engineering is more of the same with PhD. It's just a Japanese way of writing this. So I was in Osaka for basically 5 years, from 2014 to 2019. And during those times, so I was sent to École Centrale de Nantes. So École Centrale de Nantes is in the west part of France, facing the Atlantic Ocean. So I was there for 6 months, doing research about the Navier-Stokes sulfur, or people usually know it as CFD program. And during that time as well, I did a research internship in the NMRI. It's a National Maritime Research Institute, Japan. It's actually in Indonesia, we have the similar one, the LHI, Laboratorium Hidrodinamica Indonesia. But this is the Japanese version, but it's very big. And I did the experiment 1 month. So I will explain those later as well. And before 6 months, before I graduated from my PhD, I was accepted into Furuno Electric. And then 1 day after my graduation I started working directly. So this is my 3rd year working in Furuno Electric. And so I will try to explain also what kind of research I have been conducting during those 2.5 years in Furuno. So next, because my presentation will be mostly about ship, and it can be fishing vessel, it can be any ship. But the big question is, why ship? Why I have an interest on a ship at the first hand. So this why ship, right? So actually, we can say, and I think everyone knows, and you can search on any literature, that ship is the most efficient means of transportation on this earth until now, because we don't know, the technology advancement has been very rapid, so we don't know if the ship can still be the most efficient. But the technology advance in the shipping industry itself is also very rapid, so it's not easy to beat the ship actually. And actually, it has been like this since the age of our prophets. We know the Prophet Nuh alayhi salam made a very we can say a very high performance ship, that when the earth was covered by water, so he alayhi salam can rescue a lot of people and animals aboard the ship, and then finally landed in the Judy Mountain in the around Turkey, I guess. Yeah. So I would like to compare the fuel efficiency of a ship and a freight plane. So this plane bring containers, bring things for our living, same as the ship actually. So if we have a 1 ton of a container, and we try to bring this container using a ship and plane, so the numbers here in your right is the distance covered by these 2 different vehicles. So as you can see, if you are using ship, you can cover 920 kilometers of distance. It is just an approximation, but it's from Malang to Banten. So it's from the east end of Java Island to the west end of Java Island. But if you take a freight plane, of course it's much faster, maybe 20 times or 30 times faster than ship, but you can only travel 8 kilometers with a 3 kilogram of fuel. So maybe, I don't know if my calculation is accurate, but it's from Brawijaya University to Jatim Park 3 or around there. So as you can see, the efficiency is on a different dimension. Why? Because ship is supported by water. And due to Archimedes and a lot of people contribution, we have things named a propeller, right? And that propeller actually requires only very small energy to drive the ship forward. Okay, so that's just about why ship has been my focus, has sparked my interest since I was a student. Then next word in today's title is the autonomous. What is autonomous? So why autonomous system? So autonomous system, to make it simple, is the system uh, that govern himself. So it's like a human being. So we look at something, we analyze, and we decide what to do, and we make an action. So uh, recently, not only in the shipping industry, of course, I think car industry is much more advanced, but autonomous driving by Tesla, by Volkswagen, by a lot of uh, big companies. So we want to make the ship to travel with less or minimum human intervention. Why? The question is why. We don't want to, how to say, to remove captain. We don't want to remove crew or from the ship, because it's also important to have a human how to say, the human monitoring inside the ship. But a lot of lives and assets can be saved by minimizing the human error. This human error is a very big a factor, actually. So I put two big examples of accidents that happen in this world, but these two accidents were particularly, how to say, interesting, but at the same time also famous. So the first one is the Sewol ferry. I think if a lot of students likes to watch a Korean drama, I think you can find some movie about the Sewol ferry. It happened in 2014 between Incheon and Jeju Island. So I guess I thought it was a study tour of one school or something like this. And as you can see, the ship capsized like this, turn around, capsized, and around 300 people died. So, and people ask, what is the cause of this accident? So there is no debate on it. It's purely captain's poor seamanship. So it's not too much about skill, but it's more about your integrity, your willingness to help, your how to say, responsibility as captain. Because on the day of accident, actually the ship was overloaded. Because the ship was overloaded, but the captain still want to put as much student, as much goods into the ship. So what did he do? He took all the ballast water that is below the ship so that the draft is up, and they put more people to the deck. So as you can imagine, maybe with the naked eyes, with just only eyes, we can see the ship is stable on the still water, but actually the center of gravity, so the mast, people, goods are concentrated on the deck. So because of that, the ship is very unstable in the rolling direction. So, and while sailing and having some load from the sea current and maybe some waves, but I know that day the weather was quite clear. So the ship just turned around like this, and the captain did not allow the students and the passenger inside the ship to evacuate. So the captain asked everyone to stay when the ship is starting to listing like this. So it's crazy, right? So the captain doesn't want to be blamed. So they want everyone to keep inside the ship, and hopefully, I don't know, magic can happen and the ship return to its stable condition or something. But eventually, the captain escaped when every other people died. So the captain was saved. So it's amazing accident. And the second is this is just last month. There is this PCC is a pure car carrier. So the ship move so many cars inside. This is in the shore, not shore, I think it's offshore of Portugal. So as you can see, the asset loss is almost 4,000 luxury cars. So inside the ship are the Volkswagen car, Porsche, Audi, Lamborghini, Bentley, and so many expensive cars. And some of them has a EV function, so some of them are electric vehicles. And people say maybe the cause is the spark from the battery, but as you can see, the ship is burned, is on fire, and at the end, the ship is sunk into the depth of the ocean. But in this accident, all the crew, ship crew, captain, everyone was saved because fire takes time to to travel and to burn the ship. But $400 million, I think around in rupiah is around 6,000 trillion something was lost this day, and also the the price of the ship itself. So as you can see, human error, less monitoring, those kind of thing can result to the death and loss of asset. So also, actually in my master and PhD, and also my research in Furno as well, my focus is to see the performance of ship in waves. Why in waves? Because in the real sea, there is no sea with a very calm water. It's a very rare occurrence, but most of the time, the ship is designed in a calm water condition with the assumption of calm water condition. So I don't know if you got this information already in your lecture, but when the ship has been designed and built in the shipyard, the ship at the end of the construction has to be checked through sea trial. We call it sea trial. It's the first test of that ship on its life at sea. So what is the purpose actually of the sea trial? It is to ensure that the specification written in the contract are met. So simply like the owner said, I want the ship to travel 20 knots, for example. So if in the test and it doesn't met, so a lot of contract settlement should be done, and it's has been a very big problem since a long time ago, and that's why design is very important. But in the IMO regulation, they say that the sea trial should be done in calmest possible weather condition. This is the very big point, in calmest possible weather condition. So they look, for example, in 1 week or 2 weeks or 3 weeks of a period, they check the weather forecast. They find which day has the lowest wave, the brightest sky, the weakest wind, to make sure they can evaluate the ship. Anyway, we understand that we want to evaluate the ship in calm water, but in the real sea, it is not quite the case. So this kind of videos has been used in a lot of lectures, I think. This is showing, I guess it's one of the Panamax, around Panamax size of container ship, 200 or 300 meters, but it is in storm and in a sea storm. And you know, if a ship is traveling in the southern hemisphere of the Earth or the northern hemisphere, or like in North Sea or those kind of places, this kind of storm waves, 10 meter, sometimes freak waves, 18 meter, is a very common occurrence, especially in the southern hemisphere. If you have a globe, of Earth and you see the southern hemisphere, there are very few land, right? maybe Australia and Chile and some part. So not like the northern part. So the southern part has very few land, and that makes the current waves wind very strong because there is no disturbance at all. And in this kind of sea, of course, the performance of ship is very much different with those in calm water, because why the ship is pitching, is yawing, is rolling, and the speed must be down because the water resistance is very large. And in this kind of situation, if we did not consider this kind of situation in the design stage, it can be very dangerous to asset and also to the people's life. So I write here that the ship's seaworthiness are matters of life and death. So it's really a crucial point to think about. Yeah, as you can see, even the camera cannot stay still. Okay, so but those are a conventional ship, right? Ship has a single hull, and it's a displacement ship. What meant by displacement ship is the ship displace the water because they are made to transport goods like anything, container, coal, fuel, and everything. But some ships are designed to operate in a rough seas or in a high waves. For example, this one, this is a trimaran. This trimaran is traveling in very rough seas, and you can see the ship has 3 hull, small hull here on the sides, and 1 main hull in the middle. So as you can see, it can travel, even the bow is submerged in water, going up and down without being affected by the waves that much like the normal ship. And it can even do like a zigzag test like this, and some extreme maneuver. Yes. Actually, there are a lot of design principles if you want to design this kind of ship, and I think, for example, experts like our lecturers, Mr. Sunardi or Mr. Kadafi, has a very good knowledge in designing those kind of ship. Okay. Okay. I think that's it about my motivation about why I have interest in ship and why I've been doing research on ship. So let me share about my research and a little bit about my life when I was in Osaka University, and when I moved to France, and also when I work in Furno, like right now. So as I said previously, I received a Mombu Kagakusho scholarship for 5 years. It's for master and PhD. So I literally spent zero rupiah, and I received a salary. The class, I mean the what is Jugoryo in, I don't know the word in English, but everything is free, and we got salary. So in the Osaka University, in our department, naval architecture and ocean engineering, we have this one of the main facilities. It's towing tank. I think maybe most of everyone here knows towing tank. So it's a tank contain water, and at the end of it, it has a wave maker. So it's a device that goes up and down to induce wave. And then when the waves come to this side, so we tow a ship like this, like in this picture, and we can see the behavior of ship in waves. Those kinds of experiments are the most common experiments done in the towing tank. But as you can see as well here, we also did a lot of experiment like using a robot. So this is like biomimetic robots. I don't know if I say the word correct, but a robot that mimic the movement of real animals, and it has been tried in the real aquarium. So the fish, the fish is like were not disturbed by this robot. So it seems like the movement and the behavior of this robot can mimic exactly like normal sea animals. And also, there are a lot of experiments, strange experiments, but very advanced in the theoretical field. For example, like this cloaking. So, I don't know if you have ever heard of cloaking, but I think most of everyone knows Harry Potter, right? I'm not sure, but if we are on a different generation, but in the first or the second Harry Potter, he has a cloak. So it's like a blanket when you put in your body, so you cannot be seen. You are invincible. So uh, this research was done by my classmate. So he's now a professor. So he tried to arrange numbers of cylinder, uh, and he put one object inside, and he put a cylinder in a circular arrangement, and he proved that in a certain kind of waves and in certain arrangement of cylinder, the object in the middle cannot feel the wave. So it's like you have been covered by something invisible, like invisible cloak. So those kind of theoretical experiment as well uh, is done in our towing tank in Osaka University. So, and this in the right part is my testimony written in the Osaka University websites. So it's written in Japanese. Yeah, maybe later if you have interest, please check this. But I don't know if you can understand this well. But everyone has Google Translate, right? So yeah, I think that's all about my life in Osaka University, and my laboratory is just behind this wall. So every day I hear the sound of the carriage of towing tank, the sound of waves, and those kind of environment that I've been studying in for 5 years. So let me go a little bit deeper to the research topic, but I don't want to be too detailed on this because I know students doesn't like these kinds of equations so much, right? So actually, in my research in Osaka University and in France as well, I try to combine two major problems in ship motion. The first is seakeeping, and the second is maneuvering. So seakeeping is when we see the ship is static. The ship is fixed to this point, and there is some flow of water to this direction. So the ship is like having some forward speed to the x direction, and we induce some wave. And due to this wave, we analyze the ship movement to the all direction. For example, to the x direction, and rotation around x, and y, z, and what you call the 6th degree of rhythm, surge, sway, heave, roll, pitch, yaw. So we study this through the slender ship theory. So it's a theory that assumes that the ship is a very slender object in sea. So we can, how to say, simplify a lot of mathematical problem, and also try to address the physical problem in a correct way. So that's the first one. And the second one is maneuvering. Maneuvering problem is usually, we don't really look at maneuvering problem with the presence of waves. So it's just in calm water, and we look the ship from the sky. So it's like we call it bird eye view. So and then the ship has a propeller here, and it has also a rudder, right? And due to this propeller and rudder, the ship travels and turn right, turn left, and making U-turn, something like this. So it is different because the seakeeping one is the study due to waves. The ship is static in one point, and we look on it on a three-dimension in three-dimensional wise. But in the maneuvering, we look on this problem from a 2D, from the two-dimensional perspective, from the bird eye view. And the physical phenomenon itself is very much different because seakeeping is high frequency, but maneuvering is low frequency. But maybe I will talk about it later, probably in the second seminar in next week. And by combining those two mathematical formulation, so I was able to simulate a ship maneuvering, having a turning test in waves. So the wave is coming from this direction, and the ship starts from here. And it's going like this. Okay, so the dot is experimental data, and my calculation is this broken line, and this straight line is the calculation using a conventional theory. So I was able to simulate a ship maneuvering in waves with a high accuracy. So we can apply this kind of calculation in a real sea to make sure that the ship performance is kept high. Okay, next from 2018 January to July, I was sent to West France. So it's as I said, it's École Centrale de Nantes. So the city is Nantes. Some of you like football. So they have FC Nantes in their city. It's a very small city, but very beautiful one as well. It's like European city when where all the building cannot be renovated, so they keep the red bricks and they keep the those kind of old European city feeling atmosphere. So I was sent to this laboratory because our laboratory, my professor laboratory and this French laboratory has a very strong collaboration in research. And I was sent to the LEA. I don't know if some of you speak French, but it's the Laboratoire de Recherche en Hydrodynamique, Énergétique et Environnement Atmosphérique. So it's the laboratory of research of hydrodynamic energy, environment, and atmosphere. So it's quite similar to the English, right? And my group is the H2E. So H2E is the hydrodynamic interface interaction. So it's more to the interaction of a ship with interaction between ship and fluid or waves or water. And we analyze a lot of things happening in that interaction. And they have quite a big tank, but it's not the towing tank, because towing tank is very slim but very long. But this tank is we call it square tank or maneuvering basin or anything. But their specialty is to make a freak wave, very high waves. So usually they make a model. Ship model is 1, 2, 3, maybe the largest is 5 or 6 meters. So as you can see, people is here. So if I try to draw a 2-meter ship. Okay, I don't know if my scale is correct. Maybe the ship is here. So this wave is very, very big. So this is actually quite a unique ability of this towing tank. But so you can test a lot of cases happening in the real sea, in the Southern Ocean, for example, when the water is higher than your head. So when you look straight, so the water is higher than your own. So we can test a lot of extreme conditions there. And of course, when we talk about Europe and France, I was not only studying there. Of course, most of the time I was studying, but my professor, he was very kind. He said, I have to take holiday. So as a good student, I accept that request. I went to Le Mont Saint-Michel. I think some of you know Le Mont Saint-Michel, a very big church in the Saint-Malo, in the little bit northwest of France. And of course, going to Tour Eiffel, to Arc de Triomphe, for example, and a lot of Musée du Louvre, and so many places in Paris, and also different country like Germany. I went to Swiss, to Basel, and just to travel. And one interesting story. So one weekend I was invited to my friend's house, French, in a small city, like 2 hours from Nantes. The name of the city is La Roche-sur-Yon, and when I met him, we wanted to go to a beach and just play in the Atlantic Ocean and have a lunch, and we wanted to go home, but my friend told me that it is a very rare occasion, and we were very lucky because, as you can see here, this is Tour de France. So at that day, at that hour, the Tour de France was passing through that city, and the La Roche-sur-Yon is the finishing city for that section. So we directly go to that to the road where these bikers, this rider will pass. Yeah, so I was able to see Tour de France with my own eyes, with my naked eyes. And when we saw in the television, they seems to travel not so fast, right? It's just like a people normally riding a bicycle, but when you see in a very close, they are too fast. It's dangerous actually to go close, but it was a very good experience. So I will, as Mr. Gaddafi said, I will explain also a little bit more detail. How do I apply, for example, for the scholarship? How do I get those kind of experience, those kind of chance for a research collaboration in the next meeting on next weekend? So in France, I was studying exactly the same problem, maneuvering of ship in waves, but with a Navier-Stokes solver. So we don't simplify things with mathematics. We just directly address make a model of ship, put in a domain, and use a Navier-Stokes solver to solve a pressure and anything, velocity happening in this all domain. So we can get the total wave field of a ship running in oblique waves. So what we call an oblique wave is not coming from the front of the ship, but it's coming from a diagonal direction. So this is a very difficult case for simulation and experiment. So what is different from my research in Osaka and in France is in Osaka, I use the theory, all mathematical theory. So it's the linear theory. We call it linear theory. But in France, we use the most non-linear theory. So it's using a Navier-Stokes solver. So it's like for Muslim, we have a different mazhab, right? So, or in the politics, we have extreme left and extreme right. So I was doing exactly the extreme left and extreme right. So I have to learn everything from zero, but it was a really good experience. And then next, when I returned from France to Japan, and 1 month passed after that, I was going to do experiment. So actually, it's just experimental based research in the National Maritime Research Institute of Japan. In Japanese, it's Kaijo Gijutsu Anzen Kenkyujo. So my experiment was done in actual sea model basin here. As you can see, it's not like towing tank. It's like the one in France. It's quite square, the shape itself, and you can see here these are all wave maker. So it goes up like a forward and back and like that, and to make waves. So they can make regular waves, irregular waves. They can even make a love. They can make a circle. They can make a lot of things using this wave maker, because it's I think one of the most sophisticated in this world. So I did my experiment here with my colleague. It's a Jitskai Kisai Geng Suiso. It's a HOC model basin, and for like 3 weeks, more than 3 weeks, more than most of the time I was here. As you can see here, it's like a chicken house. It's like a very small glass cage, something. So I was here, and we control all the ship, we control the carriage, we control the wave maker, we record data, and we analyze everything. So that was my 1 month from 8 a.m. to 8 p.m. at least 12 hours a day. So that was my experiment in NMRI. Then that's all what I've done in my time when I was a student. And since 2019 October, I entered Furun Electric. And Furun Electric itself, okay, it's just a very general statement, but it's a manufacturer of maritime and industrial electronic products. And one of the most famous product is actually the radar. It's a marine radar. Yes, I guess Furno has around half of world share. So if you see a ship passing on the sea, and if you see a radar above at the top of the deck, so from 2 ships, 1 is Furno. So it's simple as that. And I was because I have a PhD, I have experience in detailed research about ship and ship control. I was placed in this. It's a Research and Innovation Center, Intelligent Control Technologies Laboratory. So it's a Gijutsu Kenkyujo. It's a R&D center. Daiichi Kenkyubu is the number one, first research department, and this is Jinosei Kenkyutsu, is Intelligent Control Technologies Laboratory. So let us see the video. This is just a simple video of the introduction. Okay, thank you for keeping with me to see the the video. So as you can see in that video, it's actually the promotion video for the general product for a ship. So the ship can use the radar and understand the surrounding. It can use autopilot. You can just put in your map, I want to go here to this point and then next to this point and to the next point, and the ship will automatically navigate to those points. And you can make U-turn, you can make 90-degree turn, any maneuver using only touch, and everything will be handled by the algorithm, by the code. So that's most likely what I have been doing and what I'm still doing every day until now. So the main topic, exactly the same with today's seminar title, is the autonomous ship control system. But recently, a lot of people ask, what is actually, I'm mistaken, but what is the difference between automation and autonomy? So they have both auto, but what is the difference between automation and autonomy? So automation is actually a means to control via predetermined order. So this predetermined order is the very essential words. So this predetermined orders means this order is made by human. For example, this is our autopilot. So we put, okay, we want to go to this direction, it's 295-degree. So it's to the northwest. And we click here. We push this button, and the ship is traveling. So at a lot of points, we as a human, we need to make an order. So stop the ship or turn the ship. So it's automatic. After we put the order, then we can just relax and see the surrounding and do anything else. So it's automation. But autonomy itself means to achieve the system mission through self-governed machine. This self-governed is again the most essential word for autonomy, without human intervention. So what is meant by a self-governed machine? It's like we have in Indonesia, we have daerah otonomi. So it's like that the ship can govern itself. The ship knows where she is going. The ship knows the surrounding. The ship understands what to do next. The ship understands if accident will happen, what he should do. And it's actually just like living things. It's almost like artificial intelligence, but I don't want to use artificial intelligence because it has been overused recently. So as you can see, ship can use radar, camera, and everything to understand, okay, so in front of me, there is a ship, and in my right hand side, we have a ship, and my course is here. I have to make sure that the ship doesn't come here and collide with me. And in the far distance, we have a wind turbine, so I have to avoid those areas, things like this. Those should be done by ship alone, so without human intervention. So that is what we say, what we call with autonomous ship. So I've explained it a little bit, but the autonomous systems has 4 essential functions. So those are monitoring, analysis, decision, and action. So to explain those in more detail, first, monitoring. Monitoring is sensing or seeing things. And analysis is to analyze what is happening. And using those analysis, for example, analyzing ship motion, and then you need to make decision. Actually, this decision is the most human part. We can use action, monitoring, analysis using computer, using camera, using radar, using anything, but decision is the most human part. But we need to replace this decision also with computer, with algorithm with code to make sure that the sailing and the shipping industry to be more safe, more efficient, to support actually a human, not to replace the human itself. So let me explain, and also action. Action is actually just to turn the wheel of ship, to turn right, turn left, reduce the speed, increase the speed, and those kind of things. So let me explain one by one in more detail. Firstly, the monitoring. So as I said, it's seeing things is to establish a situational awareness of the process it is executing. So process it is executing is in ship, it's just a normal sailing. So for example, you go from Surabaya to Kobe or Surabaya to Yokohama, and monitoring is to know everything happen during your sailing from Surabaya to Yokohama. For example, there are high waves coming, and for example, using this radar, we know, okay, so there are ships here. And for example, from this echo, there is a blue echo here. We can see the direction it's moving. Okay, so it's moving toward this direction. And our ship is going to this direction. So we can understand objects in range. It can be ships, land, planes, I mean airplane and anything. And we know the moving direction as well. And actually, there are so many examples, but I want to take radar and a satellite compass. Satellite compass is also one of the most important part in ship, and it gives ship position in space on Earth. So it's a lat long, it's a latitude, longitude here, 34° north and 135° east. And we also know the speed, like this 13 knot, and ship heading, of course. So through this information, we can take this information to do analysis. But remember, those kind of processes should be done not by human, but by algorithm. Okay, then the second one is analysis to evaluate the inputs which it is receiving. So from those information that we get from radar, or this is a camera, for example, we have this condition. Okay, so we know that, for example, this is our ship and this is other people's ship. So we know that this other people's ship will overtake us. So we have to do analysis, how to keep the distance, for example, how to keep the distance to make sure there is no collision. Then we have to analyze, as I said, we analyze the ship's maneuver to check the distance, to check the velocity factors, and a lot of things to make sure that the ship doesn't collide. And we use, of course, it's a mathematical formulation, physical formulation. This is the one of the most famous maneuvering model, I think, in our field. It's a MMG model developed by Japanese researchers. It's quite simple, but I will talk about this in my second seminar next week. I will try to explain this in a simple way, and hopefully I can introduce some calculation and code. Then after we get the information of how the ship behave, after we get our analysis result, then the next step is decision, is to offer options, up options for the action, and then the important thing is to decide. So like this, at first we search potential trajectories. Okay, this is the obstacle. This is the obstacle. So this is our ship. So we offer a lot of options. We can use a lot of algorithm. I think this is lattice-based searching or something like that. And to check, okay, so if we travel like this, or if we turn right, if we turn left, we can avoid this obstacle. Then decide which one is the most efficient and safe. Okay, and for example, we know the ship is traveling slowly and very straight, and we don't need to go this way to the destination. We can just go straight, keeping our course and avoid a bit and return to our course. So safest doesn't mean the best, but should be safe but efficient. Then the last thing is to execute the decision, is the action itself. So what is to execute the decision is to just to turn the wheel, turn the ship handle to the direction of your turning. And again, this has to be made all by computer. For example, like this is A, our ship, and this is other ship. And A is going to this way, and B is going to this way. So this is intersect, and A has to turn right. So in this condition, A has to do like this. Or like this. Something like that. So this is the action, the last part of the last function of the autonomous system. I have an example of the video from NTNU from the Intelligent Systems Lab. So a ship traveling, encountering a ship and making a maneuver to avoid. And as you can see, we have some sharp corner here, right? It's a waypoint. So it's a the user-defined location. Okay, let me try to speed this up a bit. Okay, as you can see, ship is coming, and we predict the ship behavior and then take action, decide and take action. Again, we have, I think, buoy or ship here. It's a very slow ship. Again, we monitor, analyze, decide, and take action. Those are the 4 essential functions in autonomous ship. Okay, let me go to the real world application for this autonomous ship. So it's a video from C machine robotics. It's the obstacle detection and avoidance. Let me try to speed this up a bit. And this is in the real world example. Monitor the possible point of collision and make a maneuver. And return to your original course. So this is other company's product, but a very a great work from C Machines Robotics. And the second one is a quite complete video, but I will try to speed it up. But it's the cargo delivery. So it's like a cargo delivery by Post Indonesia or anything. But everything is done by ship with autonomy. So from using autonomous ship. Okay, let's see. Sorry, yes. So we have operator here. Notice she brought her cup, so she can monitor the ship while she relaxes. So everything has been put in the ship, and as you can see, there is no captain here. So the ship just travel. Ship goes. This is the cross. This is the track, and this operator doesn't use handle or anything, but the ship just goes. What she did is just turn on the light, turn on some modes. It's a very simple work. Like this, monitoring from camera streams, passing one point, turning left, and again, detection, monitoring, analyze the ship motion, and decide that it has to turn like this and do the action. Let me speed this a little bit up, and like this, navigation, light, everything can be controlled from the land. Okay, I hope you can focus here. This is the most difficult part of ship handling, berthing. So to connect the ship with the port, it's the most difficult maneuver that every captain or every ship handler experience. And everything is done, and this operator, this captain goes. So it's the autonomous ship is a very beautiful and a very convenient technology to help human lives. Then I have explained a lot of real world example. Let me explain some products from Furno. This is actually an autopilot. This is quite a long video, so let's see to the main part.
これはオートパイロットが動いてませんよというサインなんですけども、じゃあ渡田さんので
I will explain in English. It's better than hearing their explanation in Japanese. So this is standby. It's the autopilot is not working, and then she push auto, and it's autopilot is working. So the course is kept 187 degree. And please note here, after pushing the autopilot, the ship will steer itself. Look, this woman doesn't even touch this handle, but we can see that the handle, the steering, is done by itself. Notice that this engine is going right and left, right and left. Okay, like this. So this is our autopilot product for smaller ship. I wrote here, let the algorithm steer the boat. And we can also do some automatic turning and things. I will just show you shortly. Yes, so, oh, sorry. Yes, so U-turn, making U-turn and just press start. Yes, you can see the background is moving. So they are turning 180 degrees, so it's U-turn, and we don't need to do anything. So the ship is turning like this. So any maneuver basically is a piece of cake. It's very easy. Then this is also one of the recent product. It's augmented reality navigation, AR navigation. I don't know if, okay. Okay, so you can see from this video that this is what captain usually see in his daily work, but we augment, we add like a new reality. So what is that new reality? Is the information of ship, information of everything in more detail. So this blue thick bar area is our course, the ship course, and this area in red is the how to say, it's like forbidden area because it has, for example, it is a land, mountain like this. They have some aquaculture, wind turbine, shallow water area that can lead to the accident. So using this kind of technology, we can monitor the ship navigation in a very much easy way. We can check the ship speed, speed direction, also a lot of information. So we know if the ship will collide with us or like this, maybe we can detect the danger before it even happened. And the main part of it actually is the navigation at night. Because when the sky is clear, if it is in the morning or in the afternoon, we can still see the ship clearly. But when the sky turn dark and like this, can you see any ship? No. So we can see only small lights. And if it's raining, if it's storm, we cannot see anything basically. But because we have a data from satellite, from AIS, so we know, okay, we have a ship here in this distance, so we can always navigate the ship safely. Okay, this is berthing aid system. I will explain just a little bit to support the crew in the berthing process. As I said, the docking process is the most difficult maneuver for a ship handling problem like this. We can know, okay, the distance between the ship to the port, we know the ship speed, we know the ship heading angle, and how to manage everything like this. This is very important recent product from Furuno. Okay, so this is my last slides. This is, I'm sorry, but finally, I go inside to the fishing technology. This is a multi-beam sonar. So by using this multiple beam from the sonar, we can detect fish schools and also seabed profile, for example. And it can reach 300 meters of depth. It's quite deep, but it's not that deep. Yeah, but it can still be improved. I think a lot of people doing research on this. So the most important thing in this DFF 3D is, as you can see, we can see the size of fish school. We know the depth of the sea, we know the size of fish school, and with some additional tool, we can know how big is the ship, how big is the fish. For example, this is 100 kilogram or 500 kilogram schools or something like that. And it can be used, of course, for the fishermen and to get much more big catch. So not like the ship problem, I couldn't explain this in too detail. But if you have any interest later, please contact me anytime. Okay, thank you very much. That's all my presentation from today. The Furuno Electric, our core technology is to see the invisible. So in Japanese, it is mienai mono miru. So not only ship, but also
has been helping people see things that
a lot
are
of
beyond
things,
the realm of visibility.
like
Problem. With our unique technology in line with the times, while carefully observing its impact on society and the people who live in it.
Okay, let's see the video. I'm sorry.
Envisioning the future of marine resources. Utilizing our exclusive technology that distinguishes fish species and size, we are revolutionizing the fishing industry while also helping to sustain the abundant marine environment. Envisioning the future of marine travel. Bringing together the most advanced navigational sensors and communications technology, we provide the ability to search out optimal routes that consider safety, environmental, and economic factors. And for long voyages, we calculate the optimum and most economical routes for safe passage. Envisioning the future of marine recreation. We provide products that bring a world of fun and excitement to boating, while keeping family and friends safe from dangerous situations. Our instruments help people plan their time on the ocean and even enable them to encounter the beauty of marine life. Envisioning the future of society. Our technology is pertinent to many aspects of society. It can detect diseases in their early stages and reduce the burden of medical treatment. It can also help to create stress-free, enjoyable, and comfortable modes of transport. And it can detect potential danger in various places and protect the people who live and work there from them. The products Furuno manufactures go far beyond making things visible. By making the invisible visible, we encounter new possibilities that we weren't aware of before. This not only benefits those who operate our instruments, but it also affects the lifestyles of many people beyond them. By looking at things from a customer's point of view, we can see the problems at hand and find new possibilities that were previously beyond the realm of visibility. And by analyzing the way people live, we at Furuno will continue to create new values yet to be visible to the human eye. Challenge the invisible.
Okay, that's all for me. Thank you. Next week, I will explain things about ship hydrodynamics, theory and application. Thank you very much. So time is yours, Mr. Moderator. I'm sorry if I took too much time.
Okay, thank you very much for Mr. Ardana to deliver the interesting material for us, and then it is help us to well understand about the navigation, not only for autonomous, but also for navigation system and recent technology in navigation. Thank you very much. And now I'm going to start a question and answer session. So please, for all of participants, to ask question to the speaker, and if you are not confident to using English language, please no problem using bahasa.
Yes,
or
sure.
bahasa Indonesia.
Saya belum lupa bahasa Indonesia.
Terima kasih Pak Dana. Jadi di pengalaman yang sangat bagus memberi wawasan kepada mahasiswa kita tentang apa itu teknologi 4.0 ya sekarang ya. Jadi eranya sekarang bahwa teknologi itu basisnya data, ya, database. Terus berikutnya ada suatu mekanisme itu dijadikan kontrol untuk autonomous, jadi semua serba robot. Ya. Ini salah satu teknologi maju di dunia perkapalan perikanan. Ya, saya pikir terlalu jauh. Maksudnya kalau sekarang base kita kan sekarang bahwa perikanan di Indonesia itu tradisional. Jadi bahkan kapal kita itu tidak pernah berubah sejak zaman dulu kala. Ya mungkin yang pertama ya terima kasih sekali ya. Ini bisa memberikan gambaran yang nanti mungkin suatu saat nanti mahasiswa kita bisa berpikir bagaimana supaya mengembangkan teknologi autonomous ini. Mungkin kapalnya didiamkan terus berikutnya dia bisa berlari-lari ke laut untuk nangkap ikan sendiri tanpa ada awaknya. Pulang-pulang sudah penuh dengan ikan.
Betul.
Dari video tadi saya bisa menggambarkan, saya pikir sangat mungkin itu. Jadi
Betul.
nanti kapalnya itu apa itu? Kapalnya itu ngetrek mencari gerombolan ikan yang paling banyak. Ketika sudah kepadatan sekian, alat tangkapnya diturunkan, bisa naik sendiri, bisa memasukkan. Nanti mencari lagi, ya, sampai penuh palkanya baru pulang. Saya pikir mungkin mahasiswa kita bisa berpikir sampai sejauh itu ya. Ya, tentu saja pengembangannya melalui suatu riset, suatu penelitian, ada latar belakang. Pinter-pinter ini supaya nanti kembali untuk mengembangkan dunia perikanan, dunia kelautan, perkapalan di Indonesia. Ya, jadi terima kasih. Saya pikir akan mahasiswa kita juga saya yakin akan sangat termotivasi dengan penjelasan ini tadi bahwa ternyata perikanan perkapalan itu tidak mungkin dari menentukan lokasi, terus berikutnya dari data lokasi, misalkan track itu bagaimana terus transfer datanya terus ke penggeraknya itu, ke penggerak kecepatan, ke penggerak manuver gitu bagaimana. Cara sederhananya mungkin mahasiswa kita juga ingin tahu. Terus sensornya itu diletakkan di mana. Ya kejadian saya baca beberapa kejadian mungkin di Indonesia kapal-kapal kecil, kapal-kapal ikan kecil itu sering tertabrak kapal besar karena sonarnya itu nggak mendetek dari depan. Kalau manusia itu kan bisa memperkirakan, berarti kalau gelombang dari depan itu akan kita 90 derajat supaya aman, apakah kapal itu nanti mengikuti, menghadang, ataukah bergerak sejajar dengan gelombang. Bagaimana sistem autonomous itu bisa bekerja. Ya, saya pikir itu sementara. Ya, nanti mungkin silahkan yang lainnya, bahasa Indonesia saja nggak apa-apa. Mungkin kita ketemu dengan ini ya, sangat ahli maju di bidang perikanan, di bidang perkapalan, maksudnya teknologi sistem maneuvering. Silakan ditanyakan. Ini kami dari Bapak ada tim untuk lomba kapal cepat mungkin berkepentingan dengan teknologi maju seperti ini. Silakan. Terima kasih Pak Ardana, Pak Kadafi.
Ya.
Terima kasih. Saya mau tanggapin sebentar Pak Sunardi kalau boleh. Jadi terutama poinnya bagus-bagus sekali. Yang pertama itu Pak kapal di Indonesia tua-tua ya Pak ya, kapal ikan kadang-kadang sedih.
Nggak pernah berubah dari dulu.
jadi yang mancing di kita itu kapal Australia Pak. Kapal Vietnam, kapal Australia, karena kita keluar sedikit kena ombak pulang gitu.
Iya, bahkan Laut Selatan itu kita sembah-sembah tapi ikannya dicuri sama negara lain.
Betul Pak. Pada Laut Selatan luar biasa resources-nya Pak ya ikannya ya. Cuman maksudnya kapal-kapal Australia paling kecil 100 ton mungkin Pak, dia ada gelombang nggak ada rasanya Pak, disikat
aja sama
dia. Iya.
Kita masih rata-rata kapal kita 30 GT, jadi kalau
30 GT Pak ya.
100 GT, 200 GT itu sangat sedikit. Ini hanya perusahaan-perusahaan yang punya. Ya, itu kurang tahu mungkin apakah kita modelnya untuk rakyat atau gimana. Nggak tahu, tapi memang kenyataannya seperti itu ya. Terima kasih.
Ya Pak. Baik Pak.
Oke, thank you Pak Sunardi. Silakan Pak Mas Ardana bisa langsung menanggapi. Sudah ditangkap ya?
Sudah saya tanggapi satu, terus yang mengenai sistem manuver segala macam itu juga sebenarnya nggak sulit kalau kita tahu basic-basicnya. Mungkin kita programming sederhana pakai microkomputer, kita pasang di model kita hubungkan sama kemudi, hubungkan dengan dinamo untuk putaran propeller itu. Nggak usah kita pikir pakai komputer, bikin sistem remote control dulu aja biar kita tahu bagaimana dari remote control itu bisa mengendalikan kapal gitu. Ya kita bisa reverse engineering, beli remote control kapal harga 200.000, 300.000, bongkar aja. Beli 10, dibongkar, 10-10-nya rusak, tapi kita tahu mungkin cara pakainya bagaimana, cara bikinnya gimana, sedikit-sedikit. Nanti kalau udah bisa bikin remote control, ya udah. Si remote-nya itu kita ganti pakai komputer kecil, taruh di atas kapal, kita program, coba bikin jalan lurus sederhana, bisa nggak, nanti belok gitu. Itu nggak sulit kalau kita pelan-pelan, teliti, terus juga belajar ya, semua butuh waktu. Saya juga pelajari apalagi terutama teori manuver hidrodinamik ya. Saya ada satu paper profesor saya 1,5 tahun tuh saya baca baru paham sampai ujungnya penurunan persamaan integral itu. Jadi nggak ada, menurut saya tuh nggak ada orang tiba-tiba pinter tuh nggak ada. Jadi buat anak-anak nggak usah mahasiswa nggak usah khawatir kalau masih merasa nggak mampu atau semua kalau belajar saya rasa nggak ada yang nggak mungkin gitu. Silakan kalau ada tambahan-tambahan lain. Dari mahasiswa apa aja pertanyaannya? Boleh. Saya juga masih mahasiswa.
Kultur akademik di sana gimana Pak? Dibandingkan pengalaman di Eropa atau di Jepang gitu?
Kalau di Jepang ya mirip-mirip sih Mas ya sama umum di Asia, jadi cenderung mungkin malu bertanya. Tapi kalau makin ke sini anak-anaknya lebih vokal sih. Mas, maksudnya orang Jepang ya sopan ya. Tapi mereka kalau nggak tahu tanya betul, nggak malu. Aduh, saya kalau tanya begini nanti kelihatan bodoh atau apa ya. Enggak gitu, karena mumpung ada peluang, mumpung bisa dapat informasi, pengetahuan sebanyak mungkin, jadi dimanfaatkanlah gitu apa semua momen di kelas, di seminar atau di apapun gitu. Jadi kalau bisa gitulah kita motivasi anak-anak UB juga, anak-anak Indonesia biar lebih aktif di akademik, di industri juga ya. Kalau dari kultur yang kelasnya sih seperti itu ya.
Untuk pengembangan riset pengembangan ini dilakukan oleh Furuno sendiri ya, atau
Iya Pak, jadi saya
dengan Osaka?
Jadi enggak sih Pak, sebenarnya kita ada kerjasama sama Osaka, tapi di Furuno kita punya laboratori sendiri. Kita punya sekitar 6 lab. Nah, lab saya tadi masuk di lab intelligent control, khusus untuk ngurusi kapal gitu. Terus ada lab sonar, ada lab radar, ada lab akustik. Jadi kita punya 6 atau 7 lab, tapi kita ngerjakan eksperimen, ngerjakan studi teori semua sendiri. Nah, kalau kita butuh, kita kontak universitas, misalnya Tokyo, Osaka, dan banyak kampus kerjasama untuk bantu riset gitu. Dan mereka juga sering butuh alat-alat kita, Pak ya. Kita punya kapal, kita punya radar, punya alat eksperimen. Mungkin juga UB kalau berminat, silakan kalau berminat untuk eksperimen pakai kapal kita misalnya.
Iya, iya.
Ya, baik. Sebelumnya selamat pagi untuk Kak Ardana Wicaksono. Di sini saya juga mahasiswa aktif di PSP angkatan 2020. Mungkin izin bertanya, jadi kayak aplikasi apa yang mungkin kita gunakan yang bisa dipelajari sebagai pemula gitu untuk belajar lebih dalam mengenai sistem-sistem autonomous gitu. Mungkin kalau sepengetahuan saya sebagai orang awam, mungkin untuk aplikasi-aplikasi sendiri lebih condong ke pemrograman. Tapi mungkin penjelasan dari Mas Ardana mungkin bisa nambah wawasan buat saya sekaligus teman-teman juga di sini. Terima kasih, Mas.
Baik, terima kasih Grizzly. Pertanyaannya penting sekali. Jadi saya kebetulan lupa tadi saya share di websitenya Furuno itu kita punya semacam info, dia semacam textbook ya, semacam jadi yang menjelaskan basic-basic dasar tentang teknologi-teknologi radar, tentang teknologi sonar, fish finder, GPS. Saya boleh saya share screen, Pak Moderator?
Silakan.
Boleh. Misalnya ini ada GPS basic ya. Kita klik GPS basic sini. Ini dia menjelaskan semua dasar tentang GPS. Apa itu GPS? Bagaimana GPS itu bisa memberikan posisi kapal di laut misalnya. Sinyalnya seperti apa? Faktor-faktor yang membuat GPS itu misalnya error tuh kenapa? Terus banyak hal. Ini satu GPS ya. Terus ada misalnya yang mungkin lebih terkait sama teknologi penangkapan, misalnya fish finder ya. Ini fish finder ini dia betul seperti textbook, bahkan bisa untuk belajar untuk saya dan orang-orang yang juga mungkin paling tidak untuk referensi ya buat bapak-bapak dosen atau itu. Misalnya nih, ini ada topik 1, 2, 3 sampai 18 ini menjelaskan cara kerja, menjelaskan tentang gelombang suara sendiri gitu. Jadi mungkin aplikasi selain untuk belajar dasar-dasar ya, selain pemrograman, selain yang tadi saya jelaskan ya di sini juga ada hal yang bisa dipelajari di websitenya Furuno misalnya tentang ekostre misalnya, bagaimana akhirnya bisa terlihat ikan misalnya. Ini yang bentuknya seperti terbalik, ini ikan satu ekor ikan, yang ini fish school gitu. Kayak gitu, bagaimana cara pemasangannya di kapal, di bagian mana yang optimal, seperti itu semua ada di sini. Jadi ini pengetahuan gratis, nanti bisa saya share. Mungkin gimana Mas Grizzly tadi apa menjawab? Kalau tidak bisa dijelaskan lagi pertanyaannya. Misalnya ini sonar juga.
Udah cukup Mas, terima kasih.
Sudah cukup ya? Baik,
Ya,
terima kasih.
Terima kasih banyak.
Ya.
Reica Sulistiawati dari PSP 2020, izin bertanya. Untuk pengaplikasian autonomous pada prototipe kapal itu yang dapat diterapkan seperti apa ya, Kak? Terima kasih.
Baik, terima kasih. Ini mungkin tadi saya kurang detail ya. Jadi misalkan ini ya, ini ada delivery paket, tapi delivery paketnya itu pakai kapal dan semuanya nggak pakai kapten ya. Jadi ini tadi saya sudah ini dikit. Jadi tugasnya manusia cuman pasang ini, ada karton apa ya, box ya, di atas kapal. Terus sudah kapalnya jalan sendiri. Bisa dilihat di sini nggak ada kaptennya ya. Jadi Mbak operator ini, dia juga hanya memonitor aja. Jadi ini gerak sendiri tanpa ada manusia gitu. Dan aplikasinya ini juga bukan, saya ulang berapa kali sewaktu presentasi, bukan untuk meniadakan manusia, tapi ini untuk memastikan kapalnya tuh aman dia berlayarnya. Jadi tetap ada kaptennya, tapi dia hanya untuk membantu untuk menyalakan lampu misalnya, untuk menyalakan sirine kalau ada bahaya. Tapi semuanya sudah terencana, dan misalnya seperti ini, ada kapal datang dari arah kanan, yang tadi saya jelaskan 4 fungsi: monitor, analisa, terus decide ya, memutuskan, sama aksi. Nah itu dilakukan semua sama program, sama algoritma gitu. Jadi dia bisa paham sendiri ya, kalau dia bisa melihat sekeliling dia sendiri gitu tanpa bantuan manusia. Dan ini Mbak operator ini hanya nyalakan lampu misalnya, tuh lampunya nyala hijau. Dan bahkan sampai merapat ke dock ini ya, yang tadi saya bilang 1-2 kali kalau ini manuver paling sulit untuk kapal, karena kapal tuh kalau di kecepatannya sedikit itu susah dikontrol, kecepatannya rendah tuh. Itu semua dilakukan sendiri tanpa bantuan manusia. Dan udah paketnya sampai, Mbak operatornya bisa balik ngopi lagi gitu istilahnya. Mungkin sekian salah satu contoh yang ada di dunia nyata. Terima kasih. Gimana, sudah menjawab?
Sudah, Pak. Terima kasih atas jawabannya.
Terima kasih pertanyaannya juga.
Thank you for all participants. The time is up. And so sorry for mistaken. Assalamualaikum warahmatullahi wabarakatuh. And I'll give back to the MC.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, because the time of question and answer is enough, and this is the end of question and answer season. Thanks to the audience that have participated actively. Thank you for Mr. Muammar Gaddafi for guide us to be a moderator, and also arigato gozaimasu, Mr. Ardana Wicaksono, for the information and knowledge which has been given to us. May it be useful for us, and thank you for this topic that makes me and all the participants excited and interested and maybe speechless at the same time. All right, and now we are come to the photo season. Please getting ready and turn on your camera. In this season, operator will inform us if he is ready. Okay. Finally, we get to the last season in this webinar that is closing. As the Master of Ceremony, thanks to Mr. Ardana Wicaksono, PhD, as the speaker from Research Department of Bruno Electric Co. Ltd. Japan, Mr. Muammar Gaddafi, as TNT as moderator, Mr. Gatot Bintoro, Mr. Sunardi, Mr. Fuad, Mr. Eko Sulkani, Mrs. Wahida, and the audience entirely. May what we had conducted program webinar today will be useful for us. Have a great rest of your day and see you in the second round of 3-in-1 program webinar. I'm Nabila Putri Dalinda signing off and see you at the second round of 3-in-1 program. Wassalamualaikum warahmatullahi wabarakatuh.